Hello. In this video, we're going to learn about simplifying fractions. To simplify a fraction, we are going to divide the top and bottom by the highest number that can divide into both numbers exactly. Now, this is not necessarily a must. You don't always have to find the highest number. If you find a number that can divide into both top and bottom, do so, and then just keep checking is there another number. If you pick the highest, then you don't have to worry about finding more if you can reduce it further. So for example, we are asked to simplify, and let's say we have the fraction, whoa, what happened there, simplify? Let's say we have the fraction 4/8. Now, maybe you see it, maybe you don't. You say, hey, 4 can go into top and bottom, and you divide 4 into both the top and bottom, because what we'll do to the top of the fraction will do to the bottom, or vice versa, same deal. And 4 divided by 4 is 1, 8 divided by 4 is 2. Now, everybody's brains are different, so maybe you saw 4/8, and you did not see 4 going into both of them. You said, oh, 2 can go into both. 2 can go into 4, and 2 can go into 8. That's fine, because 4 divided by 2 is 2. 8 divided by 2 is 4. And now we have the dilemma where we say, okay, well, let's check further. Can we go further into 2 and 4? Yes, 2 can go into 2, and 2 can go into 4. So now we end up with 1/2. A little more process here, but we still end with the same result. So if you don't necessarily do the highest number, but you do a number that you know can go in there, that's at least a starting point. But you got to keep checking and saying, okay, can I reduce further? Can I reduce further? The thing that will help us with simplifying fractions is knowing our divisibility rules. Like knowing 4 could go into 4 and 4 could go into 8. So to start us off, we're going to start with our first rule, 2. If something is divisible by 2, that means 2 can go into it evenly. The last digit is even. And what we mean by even is 0, 2, 4, 6, 8. So we could have a crazy number. I don't know, let's say we have 97,532. Now at first glance you might be thinking, well, there's a lot of odd numbers, but what matters is the last digit. And since the last digit is a 2, that means 2 can divide into 97,532 evenly. If you don't believe me, which you should never believe me, we are going to test and see if we can divide into this number. That's what divisibility means. We'll get a whole number and there'll be no remainder. And I'll put that in writing right off to the side here. So something that is divisible, we can say divides into it evenly, or basically the easiest way to say is there's no remainder. And I'm not going to be able to fit remainder. Wow, that took out everything. Undo that. No remainder. Okay? So if something's divisible, we'll end up with no remainder. So let's see if we get no remainder. 2 times 4 is the closest we'll get to 9, because that's 8. Subtract, we got 1, bring down the 7. 2 times 8 is the closest we'll get to 17. We got 16. Subtract 1, bring down the 5. 2 times 7 is the closest we'll get. I'm going to extend my page. And we got 14. Subtract 1, bring down the 3. 2 times 6 is the closest we'll get. We'll have 12. Subtract 1, bring down the 2. And now we have 2 times 6 is exactly 12, and there is no remainder. So 97,532 is divisible by 2 because the last digit was even. So that's the rule for divisible by 2. 2 is usually the easiest one. So if we see a number, we always try to start off, can 2 go into it? Is it even? Yes, then divide by 2. And it makes things much nicer, usually. The next one we're going to talk about is 3. If something is divisible by 3, the sum of the digits is divisible by 3. So this one's a little more challenging. I'm going to start off with an easy number. Let's say I ask you, and let's try to make sure I ask you the best way, is 12 divisible by 3? Now 12 is an easy number. So what we mean that it's divisible by 3 is you can take 3, divide it into 12, and you'll have no remainder. So what times 3 will get us 12? And you're shouting 4 at me. Good. So we subtract, we got no remainder. Perfect. So 12 is divisible by 3. So the answer to this question would be yes, it is divisible by 3. But let's say we had a little bit more complicated of a number. Let's get a little bit scary. Let's say we had to ask is, I don't know, 9,540, let's see, yeah, let's just make it that, 9,540. That'll be nice. So we're asking, is this number divisible by 3? So we can do the long division, right? And let's do that just for good practice. When we do long division, we'll go what times 3 gets us close to 9, and we have 3 already. Don't stop, you got to bring down the next digit. What times 3 will get us close to 5? Well, 1 is the closest we'll get. That's 3. Subtract, we got 2. Bring down the 4. 3 times 8 is exactly 24. And we bring down the last digit. 3 times 0 will get us. So yes, this number is divisible by 3. But instead of having to do the long division, especially if we ended up with a longer number, that was nice to us, we can take the digits of this number and add them up. And if that number is divisible by 3, then the original guy was divisible by 3. So the digits, we have 9, we have plus, I'm adding up the digits per the rule earlier, 5 plus 4 plus 0. So 9 plus 5 is 14, plus 4 is 18, plus 0 is still 18. And 18, sure enough, is divisible by 3. So this checks out. So our answer to this question is yes, 9,540 is divisible by 3. Same deal for up here with 12. 12 is kind of a silly one to do it with because you know your multiplication tables. But if you did 1 plus 2, and I'm going to leave my weird 1 there, 1 plus 2 is 3, and 3 is definitely divisible by 3. So life is beautiful. So the sum of the digits, that means add up all the digits, is divisible by 3, then the original number is divisible by 3. So 2 and 3 are fairly nice. Now we're going to head into 4. In order for something to be divisible by 4, the last 2 digits are divisible by 4. So let's say, for example, we're asked is, I don't know, let's give ourselves a crazy number. 121,664 divisible by 4. So the long way to check this would be doing the long division, 4 into that crazy number I made up. The other way to check this is to check the last 2 digits if they're divisible by 4. So only focus in on the last 2 digits, 64. If you don't know, then you're going to say, okay, can 4 divide into 64? Well, 4 times 1 is the closest we get. Subtract, we got 2, bring down the 4. 4 times 6 is exactly 24, so there's no remainder. So that means 64 is divisible by 4. So that means this entire number here is divisible by 4. So our answer to the question is yes, 121,664 is divisible by 4. Now, to correlate that back with number 2, right? It said the last digit is even. So 2 looks at the single last digit. 4 looks at the last 2 digits, and I'm going to cheat and skip down to 8 even though we haven't gotten there yet. 8 says look at the last 3 digits if they're divisible by 8. So it's very nice. They're saying look at the last digit for 2, look at the last 2 digits for 4, look at the last 3 digits for 8, And you can basically find out if everything's divisible with the even numbers by just increasing the number of digits. Really, you could think about it as how many times 2 goes into it. So 2 times 2 is 4. There was 2 2's, so 2 digits. 2 times 2 times 2, that was 3 2's, get us 8, right? So there's 3 digits. That's just a trick, not something you have to memorize. Also, if you're worried, like, oh my gosh, do I have to memorize all these divisibility rules? No, they're just useful. If you have them memorized, then you're like ahead of the game. But if you don't, it's kind of just something we want to fall back on every now and then. It really helps with simplifying fractions. Let me backtrack. Number 5. So, the last digit is a 0 or a 5. 5 is very, very nice to us. Whenever something's divisible by 5, it just has to end in either 0 or 5. That's it. Nothing else. So if I gave you a question, is, I don't know, 1,192 divisible by 5? You'd look at your last digit and you'd say, hey, it's a 2, lady. Is that divisible by 5? No, it has to be a 0 or a 5. So here it's no. But if I had asked, is 1,195 divisible by 5? Then you look at the last digit and you see, hey, it is in fact a 5. So, yes. If it was a 0, then it would work too. It has to be a 0 or 5. And you can also check by doing long division. The next one, 6. A number is divisible by both 2 and 3. So, in order for us to be divisible by 6, it has to be divisible by 2 and 3. Let's start off with a nice number. So let's say we're asked, is 18 divisible by 6? Now you probably already know 6 times 3 gets you 18, so yes it is. But let's use it using the directions here. It says both by 2 and 3. So let's take a look at 18. Is 18 divisible by 3? I'm sorry, not by 3. Let's start with 2 first. By 2. Well, the last digit is an 8. 8 is even. So yes, it is divisible by 2. So that checked out. And then now we can check if 18 is divisible by 3. Well, we can add the digits. 1 plus 8 is 9. 3 can go into 9 perfectly, so yes, it is divisible. So 2 and 3 work, so sure enough, this has to work. Yes, 18 is divisible by 6. And it always works. And it has to be an and statement. Can't just be one of them is happy and not the other. Both of them have to work. 7 is a little bit more complicated. There's a couple of different ways you can tackle it. It says if you double the last digit and subtract it from the rest of the number, and the answer is 0 or something divisible by 7, then it's divisible by 7. So let's go ahead and practice with a nice number. Let's say we have 672. And I want to know if this number is divisible by 7. Now you can do the long division. That's fine if you want to. But let's cheat and use this way. It says if you double the last digit and subtract it from the rest of the number. It's kind of a little confusing. So my last digit is a 2. It says double it. 2 times 2 is 4. Alright. And I'm going to subtract it from the rest of the number. And what I mean by the rest of the number is what's in the front here. We have 67 minus 4, which gets us 63. If this number is divisible by 7 or turned out to be 0, then the number is divisible by 7. And 63 is divisible by 7, right? 7 times 9 does get us 63, so 672 must be divisible by 7. Now that is really complicated, and I'm already making you think about all the other rules. It's almost easier to just go back to the original definition of what divisible means. It means you have no remainder. So just do the long division. Alright, well 7 times 9 is the closest we'll get with 63. Alright, hey, kind of cheated over there. 7 minus 3 is 4, bring down the 2. And 7 times 6 is exactly 42. And there's no remainder. So we could say this number is divisible by 7 by just doing the long division, which I almost dare say was easier than thinking about this rule. It's up to you, though. Rules are sometimes nice to have memorized because they're quick checks, especially if I threw in some more digits in the front, so make it easier. You can also apply this rule to the answer again if you want to. Like, if you didn't know 7 could go into 63, we could try this again, okay? And I know this is a little bit weird, so just bear with me. So it says double the last digit. Well, the last digit is 3, right? So 3 times 2 is 6. And we take what's in front of it, minus 6. 6 minus 6 is 0. And aha, that's the other condition. If it's 0 or divisible by 7, then the whole number is divisible by 7. Now, the rule is kind of nice because you can cheat in that aspect where you just double the last digit and then subtract it from what's in front. But it's easy to get them confused. So always fall back on your long division to check divisibility, worst case scenario. We already talked about 8. It said if the last 3 digits are divisible by 8, then the whole number is divisible by 8. My example for this one is pretty nice. If we have something like 12,000, that's divisible by 8. And that's because I made a very nice problem. The last 3 digits here are 0, and 0 is divisible by 8, because 8 times 0 gets us 0. If you don't believe me, you can always do the long division. It's almost easier than actually trying to figure out the rules. You can always do long division. 8 times 1 is the closest we'll get here. Bring down the 0. 8 times 5 is 40. And now we got a nice bunch of zeros, and we'll say we did it and not. So sure enough, our remainder, after a little bit of work, is still 0. That's all for 8. 9 is very similar to 3. It says the sum of the digits is divisible by 9. So we could go back to nicer problems, just like 3, but let's make it a little bit more challenging. Let's say, is the number, I don't know, let's say 9,120, I don't know, 6 divisible by 9. You're like, oh, you're just making up these numbers right now. You didn't even plan anything. No, I didn't think that far in advance, sorry. But it doesn't matter. We can make up any numbers. So we can do the long division, 9 into this number, to see if we end up with a remainder of 0. If we do, then it's divisible. If it's not, then I made up a bad number. 9 times 1 is the closest we'll get. Bring down the next digit. Nothing times 9 will get us close to 1. Bring down the next digit. 9 times 1 is the closest we'll get to 12. Subtract, we got 3. Bring down the 6. And 9 times 4 is exactly 36. And no remainder. The other way we could tackle this, because that took a little bit of time, alright? We could take each digit, so 9 plus 1 plus 2 plus 6. And that's why it took me so long to give us a number. I was adding the digits in my head to see if it would be divisible by 9. And 9 plus 1 is 10. Plus 2 plus 6. We got 12 plus 6, which is 18. And sure enough, 9 times 2 is 18. So is this number divisible by 9? Yes. Alrighty. Last one, and then I'll end the torture. The number 10. If something is divisible by 10, the number ends in a 0. So if we had is, I don't know, crazy number. If this number divisible by 10. We look at the last digit. It's a 3. Is that a 0? No. So it's not divisible by 10. If by some other chance we had a much nicer number, I don't know, let's make that a 0 now. If that number we're asking is divisible by 10, we just look at the last digit, and because it is already a 0, then yes, the number is divisible by 10. And you can check me for long division if you really felt like it, but we don't have to. So knowing these divisibility rules will help us simplify fractions because, and let's remind ourselves, we're going to end on this note, to simplify a fraction, we have to divide both the top and the bottom by the highest number that we can think of, or whatever number we do come up with, and divide it into both numbers until we can't go any further, right? So we'll do more practice on simplifying fractions in class. This is the basics you'll need. I strongly recommend that if you need to go back and write down those rules, do so. Have them handy. Take care.